might be taking the posters as she did last time.
Yeah, but
she has now announced them. So you may want, most people have pulled them down, but you may just want to make an announcement that she's not taking them.
no. I told them they had to take it.
I thought I heard you say that, but why are they coming up and asking you?
I don't know because last year that
Yeah, that's right. Yeah. All right. Do you want me to run around the microphone? No?
Yeah, I think we'll see it. Are you guys ready to start?
We're close, but I
Okay.
want to make sure, okay? So the first one
We're running out of people. Let's get the folks outside inside. I need filled tables. You guys look organized. You ready to start?
Sure. The bane of our downfall, being organized.
Up. Okay, take it away, first table.
All right. So I'm Sham Dwarknath again. I'm head of Scribes Anonymous. So our table, actually, we tried to build a dichotomy between two different concepts for how you harness really the data revolution. And I think there needs to be a differentiation between data and information. I mean, obviously here we want to collect as much data as possible, analyze it, but it doesn't really have an impact until you can make it useful for something, and that's when it goes from just data to information. And often we may be collecting a lot of data of which only very little is actual informational content. So being able to detect that on the fly, figure out what is actually useful, and extracting that, the information, and storing the information may be one concept that gets us to this point of actually harnessing data in large quantities across a variety of different systems. And we think that could do a couple of really interesting things. There's an example where we have for basically doing hydrology, and the question becomes, like, if you have large amounts of data, you can have very nimble, agile models that can respond much more quickly to the information that's available, whether it's the hydration of the soil, the changes in the weather, but the model itself becomes an informational content in the way in which it adapts. And there needs to be a lot of research that's necessary for that, because a lot of science domains are still using classical models from, I don't know, maybe the 17 or 1800s. So I think we need to really advance the science in order to take advantage of the data. We also need to advance the ability to actually extract information from data and not just be storing large amounts of zeros or effectively zero signal.
Sounds good. Next table. Yep.
Okay. Hello, I'm Amog Damdere. I'm from UCSD, where I'm at the CADA group. So we had a couple of different themes at the table. So first of all, we discussed that data can be easier or harder to get depending on the exact problem domain. So in some cases, data is more readily available, and in some cases, it's harder to get. In some cases, it might not be even available in a readily digestible form. For instance, it might be in the form of books or documents, which are hard to parse into to actual data. So there was the idea that can we develop models, data-based models, using data that's available readily in one domain and try to translate them into, for problem domains where data is not that readily available. So this almost leads to a sort of a concept where you have these domains and you have the kind of data sets that they're using, and you can think of it almost like a graph in some sense and try to do some sort of matching between who's using what kind of data and what might be available to use for different problem domains and so on. The second thing we discussed was the heterogeneity of data that's being generated. And this is not something that's unique to one problem domain. We definitely face it a lot when we do internet measurements, but I'm sure this is a very common theme among many different problem domains. So the idea there was, how do we actually do some sort of meaningful synthesis of different data types? Because often the kind of the problems we want to address are only sort of possible when you do this sort of synthesis and not just with one isolated data set. Finally, we looked at discuss a little bit about data usability at different layers of granularity. So in many of these problem domains, you have the absolute raw data, which is what people measure or collect. And this is useful for people who are actually in the weeds doing the work. But oftentimes, you have to translate that data into higher layers of granularity or abstraction to make it more useful for people outside of that particular problem domain. So there was the interesting idea of actually assigning a numerical level to data sets, being 0 meaning an absolute raw level of data where you're absolutely in the weeds, and you progress higher up the stack, so to say, and get more towards higher levels of information.
Thank you. Corner table.
All right. Amit Chaurasia, San Diego Supercomputer Center. So we had this discussion regarding the two sides of the same coin, if you will, data and the analysis. And so one thesis was that we seem to be in a data holding phase currently. And the data needs to be handled in a very domain-specific way because some data does require very, very longitudinal view of things, such as astronomy data, whereas other data may not be, the longevity may not be that important. And then there are still major gaps in availability of data of different sorts. For example, environmental data in not so developed part of the world is not very well, sparsely available still. From the other side of the data equation is that we are going behind, we are running significantly behind in the analysis of this data. And so a very, very strong effort is needed to create new ways to analyze this data. Ultimately, we are after some sort of insight or knowledge. And we are spending significant effort in holding and collecting this data, but then even stronger effort needs to be created or applied to actually get something out of this. And so that would be a key thing for us to kind of get true value out of the data ecosystem.
Great. Let's see, yeah, exactly.
Hi, Shantanu from Rutgers University. Harnessing the data revolution will require a revolution in the way we harness data. That's not a tautology, I repeat. Harnessing the data revolution will require a revolution in the way we harness data, which really means that we need a more careful, systematic study of the requirements. We've done requirements, we've talked about simulations, we've talked about many of the grand challenges, but at this point in the journey of harnessing the data revolution, it appears that this is a messier, more complex space than what we may have encountered earlier in the, let's say, simulation space. So to that effect, we collectively thought that making sure we did careful requirements analysis across the communities involved is important, and both across communities. And the score might be across the communities, but also maybe deep inside a community. And maybe just one thing worth mentioning, it as we were talking about requirements, it came out that maybe communities are not the right abstractions all the time, because the variation in requirements within a community may at times be larger than the variations across communities, which in turn leads to the notion of requirements that are trans-community, i.e. what might be the motifs, what might be the equivalent of the dwarfs, the Berkeley dwarfs in high-performance computing that might help us understand requirements here and build infrastructure around those requirements here in the data revolution.
So I'm Bill Talone. I'm with the University of North Carolina at Charlotte. And we discussed a number of different things. I'll try to highlight two. One of them overlaps, particularly with some things that were just mentioned. But the first thing that we haven't heard a lot about, unless you've been at a table that I've been sitting at, is that in this future, the user experience matters. And this is largely a sense-making process. When we're trying to make sense of data, small data, big data, complex data, so the way we see our data, the way we interact with our data can either help us make sense of that data, or at times it can actually be an obstacle to making sense. So, and that's true whether we're doing exploratory analysis or directed analysis, where we have a particular question in mind. And so the thing that I've mentioned at several of the tables I've been at is that this is really a social technical problem, not just a technical problem. Yes, we need tools. Yes, we need different technical solutions, but we also have to think about our participation in our use of the data. And then the second is somewhat related, and it really echoes some of what was just mentioned at the previous table. And that is that, let me get to my list, that we need to baseline requirements. We need to baseline the tools and the methods that are out there that are being used, in part because that we can then use that to create greater awareness of what is in our toolkit and what are those methods that people are using and how are people interacting with their data and experiencing the data in that sense-making process. But then to stretch that forward-looking. And we may not be able to prescribe what the future is going to be in this space. That future, that solution may be more emergent than something that was conceived and then prescribed. But as a community, all of our DIBS PIs, we could be a part of articulating a pathway towards discovering that future. And what are those key things, those key requirements, again, that need to be addressed, from curation to security to privacy to analytical tools, to the user experience in how they interact, how they see their data, how they interact with their data. I've seen this done in other research, emerging research and development communities, where it's not clear what the solutions are going to look like, but there's enough experts in the room to articulate what are those requirements, what are those criteria that should be considered as a part of those ultimate solutions, and where should the investment be? What are the hard basic research problems? What are the hard applied research problems? What are those problems that are really just their advanced development? And maybe that's not in NSF space, but that doesn't mean that this community can't look to work going on in that space to prop up and to leverage the work that we want to do and we think is necessary to realize this vision. Did I reasonably well?
Thanks.
Okay, thank you.
Next table.
Our table is very small, as you see. We hardly have a quorum. Also embarrassed to say we started discussing only when you told us we had 5 minutes to discuss, to finish it and to get rid of our posters.
That's what the warning's for.
Nevertheless, we have 2 points. One is a point that somebody made about data curation. Where once the data sets are going to get very large, we cannot really remember or depend only on humans doing it. We need maybe AI or machine learning solutions to help us. Other part is that we might want to have a kind of a global vision of a large distributed storage system, whether provided by the NSF, like the Open Storage Network or other things. And one question that came up during our discussion, however short it was that it's very easy, even now outside of physics or astronomy, to produce very large data sets very quickly. So if you have 100 petabyte data sets, even an open storage network would quickly be filled up. So how would we decide who gets to access, to store the data there? That was it, sorry.
So our table echoed a number of the considerations that have already been mentioned, specifically around better tools around decision making for what gets stored and how, but also one piece to add to that might be to better train for efficiency in storing code. And when you're thinking about in a prototype kind of situation, then how does that scale? That you could get better advice perhaps, or better efficiencies, thinking from the beginning about what you're going to do once you're collecting these very large amounts of data. So two other points that haven't been raised yet so far in this discussion. One was around recommending better cross-training between teams, so between CS professionals and domain scientists, both ways, to try to get some more depth, and perhaps this issue of cyber workforce development could be addressed in this way if we get some better cross-training between the domain scientists and the computer scientists. And finally, another recommendation was around software and software testing, and perhaps some kind of certification or peer review process for software in order to avoid errors that then are replicated or propagated when software is compiled and larger programs are built, so that this can result in very large problems if it's not caught early on.
Okay, hi, I'm Rob Gardner, University of Chicago, and our table talked about a number of things having to do with what we'd envision, the kind of infrastructure, the kind of architecture that we think would be useful for harnessing a data revolution. And so we talked a lot about interfaces between different layers and what those might look like. We talked about a reference architecture with, for example, where a workflow system might be, and where a data system might be, and how does it actually communicate through the layers, and what are the abstractions that we think user communities and people who are building advanced workflow tools would want to see to access the underlying resources. So there are a lot of different areas of that we talked about in detail, but the third major point was really that it's very difficult to sort of envision this top-down a priori, that really the way forward would probably be more organic, and that we really need our discussions and collaboration and trial platforms and test workflows, and look at points of interoperability, for example, between systems, and with attention paid to the interfaces between those major functional components. Did that capture what we said? Okay. Great.
And that's all the tables? Good. Thank you very much. And we're now almost done. My program committee, Ken and Bonnie and I, have conferred and decided that we would cede our time to Amy Walton, who is why we all are here. Her having asked Tom and me to help organize this back in March. And I just wanted to thank all of you, because although organizing it is a fair amount of work, it's not much fun to organize it if nobody shows up. And so the fact that in spite of how busy all of you are, you were willing to take time out of your schedule to come here for a couple of days. And the thing that I've found most heartening about this meeting is many of you had not met others in this program, even though you're dibsters. If you can get the secret sign for I'm a dibs person. Just this continual engagement and cross-linking and sharing of ideas is extremely productive. And so I just wanted to thank all of you for what a good use you made of this time and for your coming here in the first place. So Amy, you want to make a few closing remarks?
One of the most interesting metrics is, as we all know, this time in a workshop, usually there's 4 people left. And I really appreciate the continued high levels of energy and participation throughout all of these activities, because we needed your input. This really is important to the foundation in general and to our program in particular, because I do think that we're at a milestone in this project. Is that it was my privilege to arrive just after the first set of DIBS awards were made, and there were 4 large projects made then, and there are now 54 of you across every discipline within the foundation, and tackling every kind of question that faces the research community in the area of cyber science. So again, I would reiterate what Larry has just said, is that we went from a rather frightening potential future for these kinds of activities to one where it was not only flat, which is the new up, but that has potential in a couple of areas, the data area being one of the ones that seems to have the most traction. And so once we learned that, and realizing that we are about to get all kinds of questions as to, well, what does that mean? What could you do? What is going on? Realizing that there's over 50 activities that you've stolen back your posters, but basically that thank you for those summaries of what you're doing, because you cannot imagine how important that is. When we get calls, we don't have very many minutes to respond. There's none of this, well, let me think about it and get you some text in a week or 2. It's like now. And so rather than calling you on your vacation days, which we've already done that, that's today, right? You were all supposed to be on vacation with your families. This is the time of year that you have a little more relaxation time. You were here, you provided those inputs, and they will be extremely helpful to us. So having the background, that was the first set of activities that you brought in today, and I don't think that there was a one that I could not, and which many of you are starting to see, that I could not have an NSF presentation on. I could not have, some of you have done things like made presentations to Congress. It isn't bad that some of you have been involved in some activities that led to Nobel Prizes. Thank you very much. It's been a very productive 5 years. So I'm most grateful for all that you folks have done with your time and effort to this point. I think we have a very rich set of activities from which we can answer a lot of important questions. What I do want to also do is not only to thank every one of you, because each of you was, whether it was a table spokesperson or a lead for a panel or things like that, there was a particular thank you to the organizing committee, to Larry Smar, to Tom DeFonte at the back. Richard Moore is, typing away. Thank you, Richard. To Sue Fratkin out in the hallway, that I guess you also had Charlie Irwin, so I want to publicly thank you for all of the help with putting up the electronics for this activity. For our director back there, Jeff Weekly, for getting this all information together, because that's going to be a heck of a fire hose to drink out of for the next few days and weeks. And obviously to the rest of the organizing committee, very, very important, Ken Kettinger and Bonnie Hurwitz, thank you. I know that was a lot of effort, because how do you take and organize so that when people do come to town, it's as efficient as it possibly can be? And I can't imagine ways that it could have been better. Thanks to you all for that activity. So I think in what's going to be happening now, there's sort of a near term, and for the first time, some of the people that are in the room today, between now and the next time we get together, will be graduating from this program. So some of them will be leaving. But what I will also let you know, which is taking up a lot of our time because there were 475 proposals to the CSSI program, which is the new combined activity. There will be new colleagues that you will be having in the next round of activities. So I do think we're at a point where do we go? What do we do? What are the most meaningful places to go forward? There's some short-term changes of people, but in the long term, we're basically trying to strengthen the research ecosystem. That's not necessarily just the academic ecosystem. There's a lot of activities in industry, internationally. There's a lot of directions we could go. This has been very helpful to me and to our program. What are the most fruitful opportunities in the near future? So there's a fire hose of information in all of the electrons that you folks have provided, and you'll be seeing the report soon, but that provides us, along with the background information you've been providing over the last 5 years, to get ready to move forward. So I don't know the exact next steps, but I do know there were an awful lot of very useful suggestions, everything from the Datasaurus is like, so what is going on? Yes, I know there are people that said, can we vote on that title that Jeff suggested? But in any case, just what is in the program? And then, of course, all the mechanisms for collaborating, next steps for going further. How do you involve industry? How do you involve other agencies? Some of them are here. Some of them are already involved in multi-agency activities. How do you get the various organizations to work together? So I've been listening. I don't know that I have answers yet, but I think it's a very important and fruitful area that I think could have growth potential and obviously immense productivity implications. So again, I won't hold you too long. I don't know about you, but you know, there's a lot of, there's that fire hose provided a lot of information and a lot to think about. So thank you all for your time and for, again, taking on such short notice out of your scarce work life. Certainly this is getting to be your time to be on vacation, but thank you again. And if you have any questions, please let us know. We'll be sending you the report. I'm not exactly sure when and where the next meeting will be, but I know that we've gotten a lot out of this one. So again, if I may, thanks to all of you and to the organizing committee for all that you have done. Okay. So go enjoy our nation's capital.